I don't know if the link is working well. Can you hear me? Can you let me know in the comments of the live streaming? Okay, you are here, Shyam. I'm checking now with the people in the live streaming from LinkedIn that may be there. But in any case, I think that's okay. Awesome. Let me check this up. Awesome. Okay, so let's get started. We have everything sorted out. Shyam, you're with me, right? Okay, great. So, in this case, we are going to start covering machine learning with this data set, which is the energy generation in Spain every hour. Okay, we have in the data set every row representing one of the technologies that generate the energy per year, month, day, and hour. If we load the data sets, we first, I'm going to do it with a new, well, I'm going to check it here. We import pandas. I will start a bit from the beginning, Shyam, but never mind. Read Excel, and inside the data folder, we have the data set, which is P48XLSX, which is an Excel file. Therefore, inside the parentheses, inside the data folder, we go to P48. We execute. We wait a bit until we have the data sets, and here we have it. Good enough. Now, since I want to work with this table, I need to save it into a new variable. Therefore, df generation. That's how I am gonna call it. Df generation. And I want now to create some machine learning models to see, for example, which technologies are most correlated to each other so far. Later, we can move on to the trends of the generation per technology. How would you do that? Shyam, would you know how to approach it?
So what we can do is like we just split the data set
Okay.
get we'll just convert those categorical variables into some kind of.
That's it. Since we want to compare the different categories, we need to have the categories of technologies separated in each column, right? Or each variable.
Label
How can we do this? If we apply the pivot table, there is a trick that I ask for the values.
Okay.
In the values, I want the generation.
Okay.
Megawatts per hour. Let me check a second.
We need still more to.
Now. And in the index, which is the following question, I want to take into account all of the data so far. So I can put index equals none. And within each column, I want to have the technologies. Therefore, columns equals technology. We execute, and there we have this data set, but we have the aggregated data for the generation. Nevertheless, I don't want here to apply any mathematical operation. Therefore, I may need to use the pivots instead of pivot table, which are two functions. But I think I will get this error. 1 second. Index, no defaults. Yeah, we don't need to use it. Nevertheless, at the end of the day, I think we need to aggregate by the data of the hours. Otherwise, it will not allow us to do it. So let's work with the pivot table, values generations, columns technology. And now in the index, from the data in the generation, we will group by the timing data. We copy and paste it here. And now we have every technology in each column, right? Good. I don't know also. Give me 1 second because there are some people here. Okay. I'm sending you a message on the LinkedIn live streaming if you want to join for the live Zoom, and we have a more entertaining session. So let me participants. Okay, good enough. So now let's start by little bits and then we build up. We have the data frame for the technologies in this data frame. Out of the data frames we saw before, we can see, for example, the previous data visualization, the DF generation in the pivot table. I can copy paste the codes from here. Yeah, this one. There we are. So in the first part of this workshop, where we have been creating pivot tables, like this one that you see here, we transformed the data from DF generation, where we have 96,000 rows, the hourly energy generation in Spain for each technology, and we aggregated the information to see by each technology how much energy generation was per month.
Yeah.
Now we want to see how much correlation is between the different technologies. For example, which technologies, Shyam, would you say they behave in a similar way?
Similar way, like it's increasing.
Sorry?
The energy is not fluctuating more or less, and then among all months it is gradually increasing. Kind of those things what you are focusing on, like with the
Okay.
time increasing. Like you are saying that the technology is gradually increasing.
For
So
example, look at the aeolic and the solar photovoltaic.
okay.
In the winter months, the solar photovoltaic has
Pretty,
less generation, right?
but more or less Recolic has been much better than every other generation. While seeing the values like 7, 4, it's outpassing all those technologies.
Yes, and we will move on to compare all of the technologies, but at the beginning, we will focus on only two parts.
Okay.
1 second, because there are people who want to join. Give me 1 sec. Okay, maybe there is one person that will join now. I'm checking in. Sorry for interrupting.
Right now, what we are doing is machine learning model creation or like analysis, PDA.
We will do before an analysis, and then we build the machine learning model.
Okay.
Because it will be a pretty basic model, but we will build up on these methodologies over time. But yeah, because if you think about machine learning, it's more about what would you say in machine learning? Like what would you expect from machine learning?
You have to go for analysis and then feature engineering or which sort of data set is more appropriate to make the model more accurate kind of thing.
Yeah.
First analysis and then creation of the models depending upon the hyperparameters.
Yes. At the end of the day, a machine learning model is a mathematical equation.
Okay, yeah.
Right?
Yeah.
So in this mathematical equation, since this is the first workshop, I want to make it a bit simpler and say that at the beginning, is there one variable that we can relate to any other by calculating some numbers, A and B multiplied to X? In the case of energy generation by technology, it will be, for example, how much will increase or decrease the aeolic energy based on the solar energy.
Okay.
These are many.
How well it is over associating or underestimating kind of.
Sorry?
How you are comparing? We are just comparing what are the technologies, whether the technology is making progress with respect to others or underperforming or over.
That's it. We are seeing which ones progress and how much. We are measuring it specifically.
Okay.
Right? So in the data, what we need to do at the beginning is selecting these two columns. And then later, we will compare all of them together so that I will provide you more insights on how to automate these processes.
Okay.
So in the data sets that we have, DF, how can we select aeolic, and solar energy. We go here, aeolic, and now we select solar photovoltaic. Makes sense, right? Good. Now, if I want to see the relationship between these two variables, what would you do?
Or correlation COR of
Like you would like to see in a map or a visualization,
so
what is the trend of each point, information point of aeolic energy and solar photovoltaic? How do they correlate between each other? To do this, we need to apply a plot of a scatter, which is of points. If I get inside the data frame, and then I look for the function plot,
okay.
I press the dots because this is an instance.
Okay.
I see here the scatter, right? And now they ask for X and Y. I can use X aeolic and Y solar photovoltaic. Voila. Now, there is one problem here. And now we start analyzing the data in more detail. You see that there is a lot of points here, right?
Yeah.
It's very messy.
Yeah.
That's because we are having the hourly information. How many hours do we have for each data?
Each day just 12, 24
Almost
hours.
9,000.
Okay.
So in this case, we should aggregate the information by months or days, or even,
Days. Days. Okay.
Yeah, we could do it by days. We could try. Therefore, I want to group the data by each
Day.
year and no, each day. No, but if we group by each day, we will get just for each day 31 rows. We
Okay.
need to account for the years and the month as well.
Okay. So
Year, month,
day.
and day. Yeah, and now we are aggregating correctly. But there is a catch here. If I execute, it has worked. I would not have expected because these rows are not at the same level than the columns, but apparently they have. Fair enough. So now I will calculate the total generation by each day. So sum, and then I have for each day the overall generation. Now we have 35 days.
Okay.
So we save it back into the data set. Let's call it df year. And let's plot it below. Executes. And now we can see it better, right?
Okay.
Now, but still there isn't any relationship here, right? Like the data doesn't behave in a common pattern, we could say. What shall we do now? Because I do want to find some correlation between these data. This type of analysis are very important to understand which features of generation could you apply into the machine learning model in the future if you want to apply to put it into production, we could say. Although these types of analysis we are doing right now are made to study the viability of a project with a certain technology. It's more explaining the factors with statistics than machine learning per se, as everyone nowadays understands it, we could say. Okay, so how can we see which pair of variables are mostly correlated between each other? Shyam?
Which parameter?
like I would like to see which pair of variables of technologies are mostly correlated with each other.
So, no, I don't get how to do that. But what I'm thinking right now is like we can just loop it in the sense of
We could, do you know which measure you have to calculate the relationship between two variables? Do you know about the correlation?
correlation. Yeah, dot CO.
That's it. We apply the dot, the tab. Is there any function to apply the correlation? Core. There we have it. Good.
Yeah, we can
Now,
just
how can we make this clearer? Because looking at the information here, it doesn't provide a really cool insight. So we should apply the stylings, right? So style, background gradients, we're getting somewhere. And now we can put the axis equals none, but still this is very high. I mean, I could see it here somehow, but I think we could make a nicer plot. There is a function in Plotly that if you look in Google and you put Plotly
like heat map,
correlation plot or heat map,
Shibon, yeah, heat map.
Seaborn as well, although I rather prefer Plotly because it has the interactivity on all of the plots. And sometimes it's nicer. If I check more here, no, but I can see heat map. No. I can ask for Plotly correlation plot. Let's see if I can see another. No, this is, well, they are using here image show. So I can copy this. I bring it over. I import the Plotly.
BFF,
Let me put this here. And now if I execute, I will work with this data frame.
BFF.
And there we have it. Nevertheless, it's still very small. We can see if there is a parameter such as the height to make it larger. So height equals, let's say 700. Good. Text auto, we can remove it. But here is not going to work. And now in the color gradient, I think we can use another scale that can highlight the mapping better. So for example, oranges, the one we saw before. Yeah. And last but not least, yeah, this should be fine. I would use also in the C-min, that is -1, and the C-max 1, because you see in the color legend that they go from -40, -0.4 to 1.
We're changing the distribution of the values.
Yeah, but the correlation goes from -1 to 1, so I would use better this approach. In text auto, I could use some of the string to see if I can use 2 decimal points, but I don't remember df px image show 2 decimals. this one here. No, now what can, let me check. Text auto. Yeah, this one. Point to F. There we have it. Good. So going back to the question, which one of the technologies relate most to each other?
Solar photovoltaic and solar thermal. Yeah,
Like I see, for example, eolic, which is minus 0.58
with respect
with
to
combined cycle. Also, solar photovoltaic and solar thermal, right? And it's normal because the only difference between solar photovoltaic and thermal is that the photovoltaic is from the photons of the sun, and the thermal is from the heat that stays within the soil. We can see the visualization between these two. So instead of visualizing eolic and solar photovoltaic, we can use the solar thermal. And there we can see a better relationship between these two, right? I think that we have another participant. You're not going to be alone now. Hello, Alka. Check. I think you need to put the mic on. Connect audio. We are waiting for one of the participants that have joined the Zoom session to put the mic, but it's okay. Later you can do it. Or if you have any doubt, let me know. 1 second. Okay, so going back here, Xiam,
yeah.
How can we calculate the mathematical equation for this apparent line that we see on the trend of the data?
So we can just draw a linear relationship like y equal to mh plus c.
Okay, can you control my screen? 1 second, remote control. Now you can, I think. Hello, Alka, can you hear us?
Yeah,
Nice. Now?
thank you for joining me.
Perfect. Pleasure. Like, I really appreciate you engaging with the workshops. So we are now covering the machine learning part. We are going to develop a machine learning model to predict how much solar photovoltaic will generate the technology based on thermal. For example, solar photovoltaic equals some number added to B multiplied to solar thermal. We need to find the numbers A and B such that we can calculate, given a solar thermal of, let's say, let me put it here, equals 5, how much solar photovoltaic will we generate? So to reply this question, Xiam, which will be your approach?
So what's just like training, like splitting the data sets into.
Okay, but so you're now thinking on the typical part of splitting training and test set, etc., right? I don't think I can hear you now. Can you hear me? Yeah,
Yeah,
okay.
good.
So we could do so, but so far, let's keep it quiet because we are trying to find out about the relationship between the solar photovoltaic and solar thermal. Later on, I will do the train test. But right now, if you want to apply the linear regression, what would you do?
So what we can do is we just make split the data set. We just make X as solar thermal
Okay,
and Y
so
as
from this data, we will take the solar photovoltaic
yeah,
on one side, which will
Yeah.
be the y variable,
Y, yeah,
and the other one will be the
X.
solar thermal, the x variable, right?
Yeah.
Good. Now, what shall we do with these two data objects?
So since but it is not structured in the like what you can tell that. Like we just need only the values component. We don't need the
Okay, we can use values, but we can work with both of them. It can be also in the any format. So as it is not still necessary, let's move on to the machine learning model.
So what we can do is we can like since it is a matrix, we can just multiply and then like inverse a x inverse of a
Okay,
inverse
but
in-
remember, programming is all about applying function to objects and
so
transform them into other object, right?
yeah. So
Which function will transform x and y, these two data points?
so we just define a linear function which gets x
That's
and
it.
y.
That's it. Into the mathematical equation of the linear regression. Now, since we are some 4 people already, I will ask some questions and you can let me know in the chat. Okay? So in this case, I don't know if you have worked with sklearn library. Let me know in the chat. You have worked with sklearn, Shyam?
Yeah, not yes.
Okay, Nana, yes. Okay, Shyam, you told me yes or no?
Yeah,
Sorry.
yes.
Okay, so how can you work with the sklearn now? Can you import it without looking in Google?
Looking Google. Okay, so I think
Let me give you one trick. Any object that we import from sklearn is from import something. So if you press the tab, what do you look for?
sklearn.
Sklearn, and you see that this is a module, right? If I now go to the import,
Linear.
what is it telling? I can look for linear. Nevertheless, what is linear?
Again a module. So again we have
A module. So I can import it, but then inside linear model, I need to get inside to access the linear regression, right? In this case, we have many types of linear algorithms, right? And I want the linear regression. If I put the parentheses, because this is a class and all of the classes at the time to define them, they go with parentheses. We save it into the variable model, but this is not a normal convention to work with sklearn library because the linear model has many algorithms. I don't want to work with all of them. So can I just import one of them and save memory? So sklearn dot linear model, and now the only thing that I import is the linear regression.
Yeah.
Okay. Have you worked with in this way before, Shyam? Or
I've used in this way, single. Like this is the
Okay.
way it's, I forgot to tell that, but this is the correct way it's.
perfect. And how about you, Nana? That you told me in the chat that you have worked with sklearn before. You need to open the mic.
Yeah, I mostly do it that way from SK dots, like then imports the
Okay. In sklearn library,
yeah.
do you normally copy paste from Google, or are you able to develop the functions on your own from scratch?
I'm able to do it on my own from scratch, yeah.
Okay, nice. Later I will test you, huh?
Sure.
Fair enough. Okay, so now, Shyam, if we look for a function inside the model, because this is an instance, we look for fit, right? And now they ask for X and Y. If
X.
I write here, X and Y, then I have the solution. But remember, all of you, that we wanted to see the numbers on A and B, right? Nana, would you know how to reach these two numbers? The A and B?
Model dot parameter param
Model.param.
gets per yeah.
Oops, not here, huh?
Yeah.
Let me give you one trick. You see that programming is in Python is orientated to the objects, right?
Yeah.
What is an object? An object is a data structure that if you apply the dot tab, you see the instance. If you want to see everything inside any object, you use dict. Can you see the numbers now?
Yeah.
One is the coef and the other one is the intercept. So in this mathematical equation, which ones belongs to each one? We have the intercept in A and the coefficient in V, right?
Yeah.
Now,
Can I ask a question? Why didn't the model dots get parameter work out? Because mostly that's for
that's usually what you use.
yeah.
Yeah, I mean, the get params tells you which possible parameters can you configure from the class.
Oh, okay.
But after you calculate the mathematical equation, if you want to know which are the numbers in the mathematical equation or information related to the model, you need to get inside the
Dictionary.
Yeah. But I mean, the dictionary is like, I don't know the word, like the typical helper when you don't know what to do, like the millionaire call.
Yeah.
If you want to get inside the object and you don't know what's inside. Like you can also apply to any other object, like the data frame. If you apply now dicts, you have the same.
All right. Thank you.
Pleasure. And also for the rest of you that are in the Zoom session, I want the sessions to be really interactive. So do the same that Nana did. Any question you have right away, you can interrupt. Right now that we are few people, it will be very good so that I can make the session more focused for you to solve your doubts. Okay. Now, Shyam, if I want to apply the mathematical operation here, how do I do it?
So predict, like I'm not getting what mathematical.
I can, for example, let's say if we have 5 megawatts of solar thermal
Okay. So in that case, we just make a model that predict and then pass the.
Okay. If we do it with this mathematical equation,
In that
with
case,
the
okay,
5,
so you can just define a function and
Yeah.
get the.
get into it. 1 second. We have calculated the number in here, right? Manually, but we must think that this is programming. Everything must be automated. So if you want to automate this process, there must be a function that will calculate the mathematical operation. Predict, we pass the 5.
Yeah.
Can you go, Shyam? Were you controlling the screen, right?
Yeah.
You go. Press the 5.
So here you want 5.
If you think that's correct, go ahead.
Like array of 5.
Okay.
X
We
equal
will-
to 5. Oh.
That's it as well. And also, you see that in the parameter, we only have 1. So we can avoid to specify it because any number that we put, it will interpret it for the X. Okay. But right now, what is the problem? Down below, that they expected a 2-dimensional array, right? But we gave it 1-dimensional array.
Okay. So
What is this object?
you have to we reshape the value which you are passing.
We should pass a double bracket because this will indicate that we have 2 dimensions. One to get inside this list and another one to get inside the number.
Okay.
So we go here and then calculate the prediction, which is giving practically the same number than here because it's the same mathematical equation. This is a warning, but it's okay. I mean, in this case, if you want to avoid the warning, we should have calculated the mathematical equation instead of using the X and the Y from the data frame, using it without the names of the columns, which should be with the values directly, as you told me before, Xian.
Yeah.
So we use the values here and the values here, and then we avoid the warning.
Okay.
So far, so good. Okay, so since I see the participants in the Zoom are really well with machine learning, let's try to put these models into production with a minimal example. Have you ever done this? Put the models into production? Nana?
No,
Never?
no. I haven't.
Okay.
Maybe I've done it, but I don't know whether that was a terminology for it.
Okay, got
Yeah.
it. You, Alka, have you ever done machine learning sklearn that you didn't reply in the chat? I don't know if you're here, Alka. Okay, fair enough. Also, Alka, if you want to reply in the chats, you can do so. Okay, so what is putting a model into production? Is using the mathematical equation outside the notebook in a web application that companies, today we will not do it, but companies do this to automate their processes. I don't know if you know Zalando. You know them? Oops. Gosh. Do you know this website?
No.
So this is an e-commerce to buy clothing. Nana, let's say that you had I don't know, a shoe shop, and you want to sell your shoes in this platform, how would you do it? Nana?
I didn't get your question. You
If-
said,
if
what would I do
you
if I
had,
sell a shoe?
let's say that if you had a shop
Mhm.
that you sell shoes,
Yeah.
if you would like to sell your shoes in Zalando, how would you do it? You take a picture and then you upload it to your profile, right?
Yes. Oh, yeah. Yeah.
But do you see that they have every clothing categorized if they are any type of shoe? I don't know if I can change this to .com. No, it's not gonna work. But anyway, even though this is in Spanish, you can understand that they are categories of shoes. Okay.
Okay. Okay.
Okay, you didn't know that.
I do know that.
You can
Because of
ask me.
English, I didn't know that.
So right now, if you upload the picture of the shoe, you need to categorize it, right? To tell which
Yeah.
size, which brand, etc., right?
Yeah. Color. Yeah. Yeah. I get it.
But how could you automate the process of categorizing the shoes? Could you create a mathematical equation that takes the pixels inside the pictures to understand the patterns for the brand, the color, the size, the type of shoe, etc.?
I think you can create how do you call it, like a table where like they will fill it out.
That's it. You can do that, but you need to do this automatically with machine learning. So you apply a mathematical operation to the picture, and
Okay.
then the output is the category, like the brand Nike or Adidas or whatsoever.
Okay, but what was the certainty that that model will be able to pick out like these
That's
characteristics?
because I mean, I can show you this video from C. I don't know if you know linear. Do you know deep learning?
A little bit, but no, like in details. After the learning this one.
Okay. So because your question was if, let me rephrase it here. How can a mathematical equation capture the patterns of the shoe brand like Nike or Adidas, right?
Yeah.
So let me show you this video from
And
C1.
what was the percentage like what was the percentage like what was the accuracy like?
That's another thing. Okay, the accuracy.
Yeah.
You would aim to have an accuracy of, I don't know, like ideally 100%, right?
Yeah.
But it will not always be the case.
Oh,
Like, for example, I can show you this example from TensorFlow classification, image, clothing. So here we have this set of pictures related to the clothing. You can see that they come from Zalando because Zalando is one of the companies that have sponsored the library sklearn in the past to like donating for people to develop this library, etc. So you load the data with this code because it's integrated in TensorFlow. I don't know if you have worked with TensorFlow before. Let me know in the chats. Okay. Jushiam, have you worked?
Yeah, about
Okay, good. So the same way I want to explain to you how can you compare. Give me 1 second. I will quit the remote control in case you want to move on to your computer. 1 second, Sham. There you are. Okay, so right now I want to simplify the idea for you between machine learning, basic machine learning, which is the model that we created here to the left side. This was a mathematical equation that we calculated the best numbers to calculate the prediction, right? Now, in this other case, how can we calculate a mathematical equation, the numbers, that given the pixels of the pictures, we can categorize it, we can calculate the output of the category. For example, the goal here is to determine which type of clothing we have on the picture. Good, Nana? I will take you as as the main volunteer, so you can interact with me with the microphone.
Okay.
Good. Any question, you let me know. If you understand a question that I asked you, you let me know as well. I will rephrase it. So we have the classes that we want to predict for each one of these pictures, right?
Mm-hmm.
And we do this because we want to put this machine learning model into production. Like anytime we upload a picture here, it will be automatically categorized by these categories that we see to the right. This will automate a lot of time, because if your shop had, I don't know, 1,000 clothes, it will save you quite a bit of time, right?
Yeah.
So that's why machine learning is automating many of the things we see nowadays. And also because of this, Zalando grows as a company because it's making life easier for people to upload their products. You know, it's win-win for everyone at the end. Something that you would not have done ever because it would take a lot of time to upload the pictures. Now you do it thanks to machine learning. Okay, so how many pictures do we have in the data? 60,000.
Yeah.
That we can ask from this variable, train images, and the shape. And how many labels? Labels are from 0 to 9.
Right.
And
yeah.
they say 9 here because the first picture, the 9, is an ankle boot.
Okay.
And so on with the rest of the pictures. In each picture, how many pixels do we have?
20 by 28.
That's it. And this is very important because the machine learning model, the deep learning, in this case,
I need to find the best way.
let me check 1 second. There we are. So you see here in this video that we are taking the images, but we don't take all the image. We take the pixels, right? The intensities.
Okay.
And those intensities are the ones that will go into the neural network. You see that the first layer of the neural network is telling you're going to have entering 784 variables, data points. Out of those 784, you will need to classify the images, each row of the data frame, in the categories from 0 to 9. Or, in other words, in this example, you will need to classify the patterns in the pixels to these classes. So if we go below, we can take the first image and we can see the intensities of the first picture, and we see that this is a boot. Now we can see more categories of the pictures. And now let's move on to the machine learning part in the code. Nana, in sklearn you have worked before, right?
Yeah.
Okay. So do you see, 1 second. Let me check. There we are. So are you familiarized with this code? No, right?
Errors.
Okay.
No, I've not.
Mm.
I'm not familiar. I'm not familiar with TensorFlow. That's,
But with sklearn you are, right?
yeah, I am. Yeah.
Okay. So in sklearn, what we did before, at the end of the day, which steps were they? Let me do it here.
First, imported our model.
Import the model, you
which-
declare the
Yeah.
algorithm,
and we fit it.
calculate the mathematical equation,
Yeah.
you calculate the predictions
Action. Yeah.
to this,
Yeah.
and then at the end, you compare the predictions with the reality,
Really.
the
Yeah.
score,
And check the
right?
score.
So X and Y. And there we have it. So at the end, the steps in the code of machine learning are pretty simple, right?
Yeah.
Import the class, linear regression, in this case, declare the variable, calculate the mathematical equation, use the mathematical equation to calculate predictions, and compare those predictions with the reality to see how good is the model.
Yeah.
Good. This is a warning, not an error. So it's not relevant yet. In the case of deep learning, it's also the same. It's a machine learning model. If you see here at the top, they are importing TensorFlow, right?
Yes.
As TF. In this case, they import the full library. Okay. In the analogy with sklearn, TensorFlow would be this line. Now, this line, which one could be? How do we design the neural network? And you see that we need to tell it how many pixels are going to be inputs, right?
Mm-hmm.
Then at the last layer, what do you say? 10, because there are 10 categories that you would like to calculate, right?
Yeah. Yeah.
It's the same that we saw in this picture.
Mm-hmm.
Good. And now, in the
So let me ask a question.
sklearn, is like configuring this, okay? We can use the parameters of the algorithm, like the basic idea. Sorry, you were saying?
So the first layer, because if you compare to the YouTube video, you see the first layer, you have the front layer and then there's a middle one.
Okay.
Yeah. So is the first layer the 1 to 8 that we have selected from our Keras model? So from our model. So you know
Okay.
the first layer does dense, the Keras layers dot dense is 1 to 8.
In this one, you mean?
Yeah, in this one, so what was the meaning of the 1 to 8? Why the 1 to 8?
Ah, okay, this one in the middle. Okay, sorry. Is a hidden layer inside that will capture hidden patterns in the neural network.
Okay, so you can
But
we have
this,
specific values for them, or
yeah,
is your case 1 to 8?
and this case is very arbitrary. You can put 128, you can put 256, you can put 1,000. But what is not whatever you want is the last layer and the input layer. Because if you put more pixels, at the time you pass the data, it will know how to handle it.
Okay, so like comparing it to let's say decision tree or something where you choose depth and
That's
also
it.
like
It's the same.
randomness.
It's the same concept. I can do
Okay.
it even here for you. Like but also would be applicable to the linear regression. You can see that the linear regression also has the parameters, right?
Yeah.
You can change the parameter here and they will perform in another way. They will give you another result, probably.
Yeah.
In the decision tree, from sklearn tree, import, decision tree
Classifier.
regressor, model decision tree is the same. Model fits X and Y, model predicts X, and then model score to compare predictions and reality. And just the only thing that you see right now, that's here.
You had a
In the-
better score than the linear regression. Yeah.
We have one, but if we would have used in the decision tree regressor a max depth,
Yeah.
let's say 2, now the model is not so good.
Yeah.
You know, so that's the key, the big elephant in the room about machine learning. You need to find the best configurations of the model so that the precision is the best.
Okay.
Okay.
Yeah.
And also there is more to it because you need to divide the data into train test split, which is what Shyam commented earlier. And we will also have other problems. Okay.
Okay.
Shyam, the train test
Yeah.
split cross validation is something that you would like to learn?
No, I learned from this.
You already know. Okay.
Yeah.
Good. Because like as I was saying before, we had a Reddit community because I plan to do this type of workshop every week. Okay. If I know the people who are interested in attending the workshops, which topics they would like to cover, which practical cases, etc., I can make some of the workshops specific for that. So if you want to see which other possibilities can be done in the next workshops, you can leave me in the Reddit space the suggestions. Okay. I leave the link in the chat. Okay, so going back here, you see that we have created the sequential, the algorithm here. We have declared the variable. The next step is to fit the model, which is the same than the sklearn. Later, you evaluate the model, which is the score, although you should have also used the prediction, just that they do it later. Okay. But you understand the sequence that at the end of the day is the same. And then the only thing that in the neural networks is added is the compiling. Compile is a function to tell the neural network how it should learn the patterns, how fast and which type of algorithms should apply. Because do you know about the optimizer?
Yeah, optimization of
Shyam, do you know about the optimizer? Okay. So if you are curious, optimizer Keras, there is a video because you can have many multiple configurations. In this GIF, you see that the different optimizers reach the minimum error faster than others, right? Why is this important to go faster? Because if you look at Tesla AI, you will see that the amount of time to compute the algorithm that predicts the objects on the images that the car records, how many hours? 70,000 hours of GPU train. You know, my GPU, my computer has only one GPU.
Wow.
If in 1 year, that's around 8,000, hours, I think. And in the analogy, it would have taken my computer 8 years to compute that machine learning model. Quite a lot, right?
Yeah.
So that's why it's very important to optimize, like not to optimize, but to specify the best optimizers, because if you get to the best optimizer for your data, the computing time will be lower and you will spend fewer time on the computer timing.
Okay.
Good. So yeah. And then at the end you can calculate the prediction, they will tell you the category, and then you can classify to see which one of the predictions they got right, because some of the pictures may be classified with other category, right?
Mhm.
Good. So guys, I would like to have made an extra example about the machine learning into production. Yes, we can do it. Let's go. So, do you know the Streamlit library?
No.
Okay.
Now repeat that.
Xiam, do you? Okay. So right now, we will focus on creating the mathematical equation and putting it in a website. If I install the library pip install Streamlit, we can close this, and now we can open a new Python file, which need to be this type. Although in this case, we should use another editor of code to work better with the type of script.py. And that's why we will move on to VS Code. Now, can execute this from the beginning. Yeah. Do you normally work with Jupyter Lab or Visual Studio? Jupyter? Okay. So in this case, like you can work with Python in many types of programs, but some of them are better to work for specific file types. Let's wait until they execute. Okay, and now we will do the mathematical equation with these lines of code, df here. Okay. Okay, here we see the error. year. And this is because, okay. We need to apply the pivot table before that was on the, yeah. Okay. So we have the X and the Y, linear regression, and the mathematical equation. Okay, good. Now, for those who haven't worked with a Streamlit library yet, in a Streamlit library, we would create a file of Python, for example, app.py, and we import Streamlit as st. Now we can load the data with pandas library using the same line of code we did before, inside data, and getting to P48. Like this. We save it into the F, and then we can print it. How can I put this into a website application? You told me, Nana, you haven't worked with Streamlit yet?
Yeah.
Okay. So in Streamlit, to execute this file, app.py, you would open the terminal. Focus. And now you use the codes. You need first to go to the file. So in the file app, which should be, no, here is good. In the file app, you double click the rights and open in integrated terminal. Now, if we ask for ls, we can see the file here in the folder.
Yeah.
And if we type Streamlit, you see that Streamlit is an application of its own, right?
Mm.
Not only a Python library. So the Streamlit library has a function which is run. So if we apply a Streamlit run and we pass the name of the file, app.py, we open the web browser. Let's check it's running, because the data at the beginning takes a bit to load. And there we can see the data, right?
Yeah.
So pretty cool, because in very few lines of code, we have an application.
Mm-hmm.
Now, if I want to add more colors or styles, I can put rights and tell my first ML app. I save it. I click on always rerun, and there I can see the title. This is Markdown. I don't know if you know.
Yeah. Yeah, I know Markdown.
Good. So now what I will ask is, in a questionnaire, for example, I will use with a Streamlit, I will create a form that will be called, for example, I don't know, user input. And in this form, I will ask the user to input a number, right? And I will tell not which, but how much solar thermal energy will you generate? And based on this number, we will calculate the solar photovoltaic as we did before, right?
Yeah.
So I can ask here for solar thermal. I save it. It's gonna take a while quite often because it needs to load this data, which is very heavy. But to be honest, I don't think we need the data. That's also another question. Shyam,
Yes, we don't
you
need
see
the
that
data.
loading the data in the application is very heavy, right?
Yeah, we just need to load the model instead of
That's
the
it. Load the model. How can we load the model here?
we can just store the model as a pickle file in the
Nice. So you already have high level of Python. So I need to still apply the submit button. Form submit button and submit. Save it into a variable. And now if submit, print, not print, but st writes hello. Okay, so far the application, if I click on submit, let me check. Now, if I click on submit, it will say hello, right? But Nana, what do I want for the application? To say hello or to give me the number of the mathematical equation?
Yeah, to give you the number when they input in their
That's it. So as Shyam was telling before,
load the
we-
model.
that's it. So how can we in the app load the model? How can we put model equals to the one we calculated here with these numbers? We need to save it into a file. Therefore, I would use
Pickle.
the pickle library. And now with open, I put the name of the file, for example, model.pkl. I write in binary, WVV, and now pickle dump first the object, which is the model, and the file. You see here that we have nothing yet, but if I execute,
The folder, you have to put in the folder.
the model is here, right?
Yeah.
And now to load this model into the application, I need to use pickle and load it with open model pkl. This time I need to read, not to write,
Yeah.
because I already have it, the binary file. And in model, I define it with the pickle loads f. I save it, but still, if I click on submit, it says hello, right?
Yeah.
How can I use this model to calculate the prediction?
instead commit a function you have to pass
After
in back.
That's it. After the submit, model predicts, and I pass the number of the solar thermal inputs. I save it into a variable, prediction, for example. And now I can tell here the solar photovoltaic generation will be of prediction. And I put the f string to interpret the variable. And now if I put that I will generate 1000 megawatts of solar thermal,
Mhm.
I will get for 48,000 of solar photovoltaic.
So this is production, right?
Sorry?
Is this the production that you're talking about?
This is what we can understand about for production is in a notebook, you compute the numbers of the mathematical equation for a machine learning model, right?
Mhm. Yeah,
You save it into a file
yeah.
and you put it into production, which is in a form, you put it to work. But have you done this before? Of the
No.
pickle, etc.? Okay.
I've done the pickle before, but not
Okay.
the
I
stream.
get it. Good, good. And you, Shyam, you have done this
Yeah,
before, I think. Okay. But Shyam, I didn't understand you before. I think the in the mic in the background, but
No.
the
I've already done those things.
okay, you have done this before. Okay. And Streamlit as well, I guess, right?
No, I have done with fasting.
Okay. Have you worked with any other application
No, I'm
for
just
machine learning production?
production. I have just explored about how to Dockerize the model and then serve it in Azure with them. So,
Okay. Fair enough.
I'm just learning on those things.
Good, good, good. Okay, people. So really a pleasure to have you here. Do you have any doubt that you want to cover at the last time? Anything, any doubts? You can ask me.
No, but well, like I wanted to look at how we do the how we use the TensorFlow, but
Okay, the TensorFlow. Perfect. In the TensorFlow part, you would, I don't think I can, I think I can install it here. Yeah. I mean, I can pip install TensorFlow. It will take a bit. And now when it's installed, it will take a lot of time. Okay, now that it's installed, we can from TensorFlow dot, I think we need to restart the kernel and up to selected cells. Here as model, import sequential. Yeah, this is gonna take a little bit longer. TensorFlow, let me check in Keras. And I think there is some errors. Maybe if I do this. For TensorFlow, STF. Yeah. So instead of using these outputs, is one variable out and one variable inside.
yeah.
And in the middle, we can leave it as it is because it doesn't matter.
Okay.
Now we use the compile. And here, they ask first for the optimizer. By default is the RMS prop, which can be left by default. But then they ask for the loss, right?
Mhm.
The loss, at this time, we are using in our data set a numerical variable in the target, right?
Yeah.
So we need to compare using regression losses. Therefore, the mean squared error, which compares the difference between prediction and reality, squares them, and applies the average. And now in the metric to evaluate, the same. We can do the mean square error. We can summarize it with MSE. And now that the model is compiled, we calculate the fit, passing X and Y. We tell to train, I don't know, 10 times over the data. We execute, and you can see how the error is decreasing every time, right?
Yeah.
But still is very poor. Therefore, we should put more epochs. There are many more things to do here, but I don't want to ramble on many things. Just
Yeah.
give you the overall perspective. I execute. We can see now how it's improving, although not so much after a few epochs. Yeah, let's stop it here. Use just 10. And now model predicts with X. We have the predictions, and then model evaluates X and Y. And we get the error. Good?
Yeah.
Joshiam,
Yeah.
you were okay, good. Okay, guys. So really pleasure to have you here today, and thanks a lot for attending. Now that we are starting with the first workshops, and I know a lot of things about machine learning, etc., and I also know how to teach it because I have taught more than 600 people individually, one-on-one, with this machine learning, data science, etc. So it'd be great for me and for you, if you want to engage more in the workshop, to have materials more dedicated to your knowledge. And if you can let me know in this review of the workshop, which you can do it anonymously if you create a Reddit account, and also any doubts that you may have out of the workshop hours, you can ask me, and we can grow the community to have more interactive sessions and dedicated to the topics that you are most interested. Okay?
Okay.
So I leave you the link on the chat, and I will also, for the next session, the next workshop, we will work with algorithmic trading. Okay?
Okay.
By the way, Nana, I don't know how you heard of this workshop.
Yeah, I enrolled for your algo trading classes. So
Okay.
and we
But
follow each other on LinkedIn. Yeah.
okay, perfect. Because some people I know that have followed me on the last time for the algorithmic trading course from LinkedIn that we created. This is creating machine learning to be applied, machine learning models into financial data.
Yeah.
So it's quite interesting also to learn it. Also, I think that LinkedIn has a free tier for the first month in case you are interested in algorithmic trading. But I think there are some free videos you can watch. But in any case, for next Tuesday, you can click on Luma and register for the calendar, and you will see the next workshops here so that you can join. Okay?
Yeah.
Good, guys. So have a good night over there, wherever you are. Now here in Spain is 10 p.m. So time to have a little dinner and go to bed.
Oh, bye-bye.
Take care.
All right. Thank you. Bye.
Sure.
Bye, guys.